because then I get like that.
Okay, so I was explaining Voronoi diagrams, and my brilliant student just recommended that I record this for my other brilliant students. So, so the Voronoi diagram it's pretty annoying to understand in the beginning, but it's fairly simple on the surface. So let's talk about this diagram first, for instance. So these are the 3 points that you're designing the Voronoi diagram for. Okay. The goal of a Voronoi diagram is to find all of the places you can stand such that you are equally far away or the farthest away you can be from all three of these points. Okay. For instance, if you stand right there, you will be equally far away from A, from B, and from C. So you will be exactly equally far away from all three of these points. Now, if you move across this line over here, for instance, you stand here, you will be exactly equally far away from B and from C. Okay. And the farther you go, doesn't matter because you'll be equally far away anyway. So this line is basically the entire line where you can stand to be equally far away from C and B. Similarly, this line divides A and C, so that same rule applies for A and C. So if you stand here, you will be equidistant from A and C. So this allows you to kind of optimize your situation. For example, if you want to be equally far away from A, B, and C, you can stand right there. And if you want to be equally far away from C and B and the farthest you can be away from A, you can stand here because you will be as far as you possibly can from A while still being equidistant from C and B. So this is the general idea. Now, diagram two, there's a complication. So you have A, B, C, but now you also have a fourth point, D. Now, for example, if you pick this point on this line, you will be equidistant from A and D. If you pick this point, you will be equidistant from A, D, and C. Basically, to find out which points you're equidistant from, simply check which two sections are being separated by the line you're on. So you see, if you stand on this line, you are separating A and D, right? So you will be equidistant from A and D in that case. Okay, so that's basically the background behind this. Let's take a look at the question now. So on the following Voronoi diagrams, you have the coordinates of three farmhouses, A, B, and C, where distances are measured in kilometers. Each farmhouse owns the land that is closest to it. Their boundaries are defined by the dotted line. So this is farmland 1, this is farmland 2, and this right there is farmland 3. So this is C's farmland and so on. To provide water to the farms, it is decided to construct a well at the point where the boundaries meet on diagram 1. So of course, if you want to make a well and all three farmlands are obviously best friends, then they would want the well to be perfectly, it would be optimal to put it equally distant away from A, B, and C so that everybody has to make the equal amount of effort to get to the well. So that's why we want to pick this point, which is equidistant from A, B, and C to put the well. The question is, what is the coordinate of this point? How do we find the coordinates of this point? It's pretty simple, actually. So there's a bunch of ways to do this, but the I would say my favorite way to do it would be to realize that this point, I mean, what's the main property of this point? It's equidistant from A, B, and C, right? So for example, if this is XY, we don't know what XY is, right? We can find the distance from XY to A. We can find the distance from XY to B. We can find the distance from XY to C. How? The distance formula on a coordinate plane looks like this. X2 minus x1 whole squared plus y2 minus y1 whole squared square root, right? So what we can do is we can try to, that would actually be, there's a better method I just realized. Yeah. So the best method would be to realize that first of all, A and B are perfectly on a horizontal line. B and C are on a perfect vertical line, right? And if you think about it, this line is obviously going to be a perpendicular bisector of A and B. Sorry, this line is going to be a perpendicular bisector of B and C. It goes directly down the middle of B and C, and it's perpendicular to B and C because it has to be, it has to follow that equidistant kind of rule. So this Voronoi boundary is going to be a perpendicular bisector of BC, and this Voronoi line is going to be a perpendicular bisector of A and B because again, it has to go right down the middle of AB and be exactly at the center of AB. So if we find out the coordinates of the perpendicular bisectors, if we find the equations of the perpendicular bisectors of BC and AB, we can simply check where they intersect, and that will be the coordinates of this point, basically. Okay. So what am I saying? We are trying to find the equation of this line, and then we're going to try to find the equation of this line, and that'll be it. Now, thankfully, the equation of this line is very easy to find because it's a vertical line. Why is it a vertical line? Because A and B are perfectly horizontal, like they're a horizontal line. So of course their perpendicular bisector would be a vertical line. And what is the equation of this vertical line? It's simply x equals 4. As you can see, it goes through x equals 4. So the equation of this line is x equals 4. Is that clear?
Mm.
It's,
Yes.
by the way, it's a 1 point question. I'm explaining a lot, but it's a very simple question because it's a vertical line at x equals 4. So the equation is x equals 4. And this line is a horizontal line at y equals 8, clearly. And if you feel like that's not obvious, and if you feel like it's not easy to tell that it's at y equals 8, it's very easy to check that it's at y equals 8. Because if you look at the y value of C, it is 13. If you look at the y value of B, it is 3. And we are trying to find the dead center of 13 and 3, right? To find the center of any 2 points, simply add them and divide them by 2. So you get 15 over 2. Oh, that's 13 and 3, sorry. Simply add them and divide them by 2. So you get 13 plus 3, which is 16. 16 over 2 is 8, which shows you that this is indeed y equals 8. Okay,
Mm.
so this line has an equation of x equals 4. This line has an equation of y equals 8, which means that they meet at 4, 8. That is the coordinates of the point. Okay, so
Yeah.
in a general sense, how do you find the intersection of all the Voronoi lines, of the Voronoi boundary lines, basically? You just need to find out what the equations of each line, or two of the lines are, and find out where those lines intersect. And that's it. Okay. In this case, it's super easy because the two lines are vertical. Sorry, the two lines are vertical and horizontal. So they have a simple equation that you can tell by eye. But in next case, for instance, you will have lines that are not vertical or horizontal, so you'll need to find out their equations a bit more involved. So we'll see that question in a second. So that's how you find the boundary values. Sorry, the intersection value. Now, the next question is find the equation of the perpendicular bisector of AC. Okay, this is gonna be the biggest thing I say about Voronoi diagrams. Each of these boundary lines, okay, for example, this boundary line is basically a perpendicular bisector of the 2 points that it is separating. Okay, so for
Mm.
example, this boundary line separates A and C, right? Not clearly not A and B. I mean, that line doesn't look like it's separating it. It's separating A and C. So it is the perpendicular bisector of A and C. Okay. So what have I said? I've basically said that every boundary on a Voronoi is a perpendicular bisector of the line connecting the 2 points the boundary separates. So sounds weirder when you say it in English, but I hope the idea makes sense. Basically, for example, this boundary line separates A and C, right? So it is the perpendicular bisector of AC. Now, how do you find a perpendicular bisector of 2 points? For a perpendicular bisector, you need two things. First of all, you need to know what a perpendicular bisector is, by the way. Perpendicular means 90 degrees, or just, you know, and bisector means goes like through the half. So exactly through the center of AC, basically, because it's, bisector. It cuts you into two pieces, two equal pieces. So the first thing you do to find the perpendicular bisector of AC is you need to first find out the slope of the line AC. What is the slope of the line AC? Just do y2 minus y1, so 13 minus 3, because you see, you have
Mhm.
13 minus 3, divided by x2 minus x1, which is 8 minus 0. So 8 minus 0, which gives you 13 minus 3 is 10 over 8, so whatever that is. That's the slope of your AC. However, since you're trying to find the perpendicular bisector of AC, you're going to need to find the slope of the perpendicular line to this one. Okay? And do you know how to find the perpendicular, like the slope of a perpendicular line?
Is it 8 over 10?
Negative 8 over 10, very close. It's always going to be
Mm.
negative of itself. So perpendicular slope would simply be negative 8 over 10. Good. So you found the slope. You need one more thing. You need to find a point on the line. Okay. This is where the bisector part comes in. Now, since it's a bisector, it means it crosses through exactly the center of whatever AC is. Okay. So what is
Mm.
the center of AC? We call that the midpoint of AC. To find the midpoint, simply add the x values, divide them by 2, comma, add the y values divided by 2. Okay, because you want to find the mean of the x and the y values. For the x coordinate of the midpoint, simply add the x values, so 8 plus 0 over 2. And for the y coordinate of the midpoint, just add the y values together and divide them by 2, which gives you 4, 8. That is the midpoint. Okay. So you found a point on your perpendicular bisector and you found the slope of your perpendicular bisector. Okay. And once you know both of these things, finding the equation of a line is child's play because all you have to use is this little formula. Y minus y intersection equals m times x minus x intersection. Okay. So in this scenario, the intersection y value is this and the intersection x value is this, which you found earlier. So you're going to have y minus 8 equals negative 8 over 10 times x minus 4. That is your answer.
What is
So
the formula over it?
this
Mm.
this is, I don't know what it's called. I think it's called the slope intercept form, but doesn't matter what the name is. This is used whenever you have the slope and an intersection point of your line. You can plug in the intersection over here and here, put the slope here, it'll give you the equation of the line directly.
And
Okay?
the intercept is basically the midpoint we found.
No, yeah, intersection would be any point that the line passes through. In our case, since we have a bisector, we know that it passes through the midpoint of AC. Because if you're a bisector of AC, that means that you pass through the center of AC. It's like the definition of a bisector. That's why I found the midpoint and claimed that my bisector will pass through this point, because that's what a bisector means. Okay?
Mm.
Like
Yeah.
if this is AC, this is the center of AC. My claim is that since I'm finding the equation of my bisector, it will pass through the center of AC because that's what bisector means. That's what
Mm.
the bisector part means. And that's the point I found right there. Okay.
Okay. But
So that's how you, uh-huh.
I don't understand the next part.
The next, like the whole chunk.
No, the part below it.
Ah, okay. Where we put this. Wait, like the next part or the solution?
The formula under the
Ah,
midpoint.
okay, okay. Yeah, yeah, yeah. So this is new then. So basically this formula is useful whenever you like, okay, so what do we have so far, right? Let's think about this. So we have the equation of sorry, we have the slope of our line, slope of perpendicular bisector, which is negative 8 over 10. And we have a point on the perpendicular bisector, right? So we have both of those things, which is 4, 8. So we know the slope of our line and we know a point on the line, a random point on the line, right?
Mm.
Once you know both of these things about any line, when you know the slope and any point on the line, you can simply plug it in over here. So y minus 8 equals m times x minus 4. So you can just use this formula directly. It gives you the equation of your line. This is the equation of your line basically. Just by using an intersection point and the slope, you can construct the equation of the line basically. That's the idea.
Mm.
So maybe you're more familiar with the y equals mx plus c form, right?
Yeah.
Okay. So the thing is, you can like simplify this and convert it to the y equals mx plus c form. You have y minus 8 equals negative 8 over 10x plus 8 times 4, 32 over 10. Okay.
Yeah.
And then if you add 8 to both sides, you're going to have 32 over 10 plus 8. And then if you kind of simplify this, you will have So if you add these two together, you can multiply the top and the bottom of this by 10, which will give you 32 plus 80, which is 112 if I remember, if I'm not wrong. 32 plus 80 would be, yes, 112. And that is it. So now it looks like the form you're more familiar with. But as you can see, this is essentially just an unsimplified version of the equation of the line. You can leave it like this in your exam and you'll get that points. Okay.
Okay.
Point being, the moment you know the slope of a line and a point on the line, you can convert it to the equation of the line directly using this formula. Y minus y intersection equals the slope times x minus x intersection. So y intersection and x intersection are just me putting placeholders for the intersection point that you know, like 4, 8
Mm.
in this case, basically. Okay.
Because
Remember that you have, sorry.
no, because I it says equation, so I'm more familiar with it being like, oh, it's equal to y or f of x, but it's equal to y minus 8. So I
Oh,
think
yeah,
that's
yeah, yeah. I mean, it's still an equation, right?
being weird.
Just because y is not the subject doesn't mean it's not an equation. They never said
Mm,
make y the subject, right? So that's why I can hack it my way through it and just leave it like this, unsimplified. But this is a very useful thing because it helps you save time. Because
okay.
again, you can simplify it to convert it to this form by just adding 8 to both sides and opening up these brackets, right? Because see, I opened the brackets and then I added the 8 to both sides and I simplified and I got this, which is mx plus c, right?
Mm,
Okay. So everything clear?
I, yeah, I think so.
The next question is, an additional farmhouse needs to be built on the land. The Voronoi diagram has to be redrawn to show the new boundaries. So basically this D is a new farmhouse. Now we want to build a wind turbine that um at one of the vertices. Vertices means the corners basically, okay? So we want to build a wind turbine at one of these three locations. Now, what decision are we making? We're saying that we want to make sure that it is as far from the nearest farmhouses as possible. Okay. So we're trying to make sure that it is. So, for example, if we make it at this point, the distances to the nearest farmhouses would be this and this. No, this, this, and this, right?
Mm,
Because those three would be the nearest farmhouses in that case. If we build a wind turbine at this point, the nearest farmhouses would be D, C, and B. And these would be equidistant, of course, because that's how Voronoi diagrams work. And finally, if we build a wind tunnel at this point, the nearest farmhouses would be A, D, and B, right? So these three would be the distances that are equidistant this time. So we are trying to build the wind turbine so that it is the farthest from its nearest farmhouses. Okay? So for instance, if we build it in this case, you see how it's pretty close to the nearest farmhouses,
yeah.
right? However, if we build here, it seems like it's farther away, right, from the nearest farmhouses. And
Mm,
better, if we build it here, it looks like it's gonna be the farthest possible from the nearest farmhouses. Okay?
yeah.
But we obviously need to prove that. We can't just say, oh, it looks like it, because the examiner probably won't like that a lot. So what what we're gonna do is we're gonna just find out the distances from the nearest farmhouse in each of the three cases. Okay? Now
Mm,
remember that we have three cases. Uh, the first case is this one, right? But remember, I don't need to find all three of these distances because it's obvious that they're all the same. That's how Voronoi diagrams work. So I can just find one of these distances. For example, maybe this one, okay?
mm,
Because it's going to be the same as this and this. So the distance, so let's call this case A, let's call this case B, and let's call, actually A, B, and C is already a thing. Let's call this case 1, let's call this case 2 and 3. So in case
mm.
1, the distance from the wind turbine to the closest farm would be whatever this distance is. Now, do you know the distance formula for Cartesian coordinate system?
No.
So you have to find the difference in the x values, square it, plus the difference in the y values, and square that. distance is calculated like this.
Oh yeah, I do know.
Okay, perfect. So let's try to find the distance in this case from this point to this point. X2 minus x1 plus whole squared, by the way, plus y2 minus y1. Oh no, y1 whole squared, and then square root of all of this. That is the case 1 distance. For case 2, we will do the same thing. Okay. So for case 2, we can find the distance between any one of these three pairs of points. Which one do you want to find, for instance?
8 and 3 and 8, 13.
8 and 3 and?
8, 13.
Oh, no, no, no. We need to find the distance between the wind turbine and the other farms. Otherwise, you're going to be finding this distance.
Uh-huh.
So you want to
8,
do
yeah,
11, 8 and 8, 3, for example.
yes.
So 11, 8 would mean 11 minus 8 whole squared plus 8 minus 3 whole squared square root. That's the distance in the case 2. And finally, case 3. Can you tell me like just the formula for any one of the three cases for case 3?
Um,
So pick your pairs of points, two pairs.
okay. So 4 minus 0 in case
4, okay, 4
squared.
minus 0 whole squared plus,
1 minus 3.
exactly. So you're finding the distance between this point and this point.
Oh,
And as
wait.
you can see, I think by eye, um, it looked like this is probably going to be the biggest. So this is where we would want to build our wind turbine. By the way,
Did,
just,
did I do
just
it
for,
wrong? Did
sorry?
I do it wrong?
No, no, it looks perfect. 4 minus 0, 1 minus 3.
Is it x2 minus x1 or is it?
I mean, x2 can be whatever you pick to be x2.
Okay.
Like if you want, you can use this as x2, y2. If you want, you can use this as x2, y2. Doesn't matter. The order doesn't matter. Just
Mm.
don't switch up the order. Don't be like 4 minus 0 and then 3 minus 1. You know,
Uh-huh.
say
Yeah.
4 minus 0, even though in this specific case it won't really make a difference. But just as a good habit, don't do it because in slope it can cause problems. It will cause problems. Because over here you can't if you even if you do 3 minus 1 and then square it, it won't matter because squaring will ignore the negative anyway. It doesn't care that there's a negative there. Because 1 minus 3 is negative 2 and then square that you get 4. And if you 3 minus 1, that's also 4 because the square removes the negative. But just make sure you don't mix up the first one basically. Okay? 4
Mm.
minus 0, 1 minus 3, not the other way around. Anyways, so we found out what the distance from the wind turbine to the nearest farmhouses will be in all three cases. Okay. And I think by eye, I can probably tell that this will be the farthest away we can get. The reason, by the way, logically, the reason we want the wind turbine to be so far away from the farmhouses is because wind turbines are very loud. They're very, very, very loud. People don't know this because, they've only seen pictures, but wind turbines are super, super loud. So that's why we prefer to have them like really far on mountains and stuff.
Mm.
Anyways, so and hence write down the distance to the wind turbine of the wind turbine to the nearest farmhouse. That's your answer, basically. All of this work that we did here was for 4 points, and that's it. Okay, so that ends this question.